Hello and welcome to Low Level JavaScript. Today we're going to embark on a little adventure into game development. Specifically in the beginning it's going to be game engine development, but later I do hope that we move into building something interesting with the engine that we make. Now I don't want to build a complicated 3D game engine, although I do think it will be interesting to go into 3D graphics at some moment on this channel. Now is not that time. What I would like to build is something, a type of game engine that I used to interact with growing up, which I think has a real charm. And I have this website open in front of me, which is ADOM, Ancient Domains of Mystery. And this sort of looks like a top-down 2D game, but when I played this when I was younger, it was actually a different kind of game. It was actually it was based on ASCII, and you would have something like this, where this A is your character, this T would be some other character, these grey hashes here, these would be walls, and outside these green commas, these are grass, and the T's are trees. Yeah, it's a lot more of an imaginative kind of game. You really have to be able to use your imagination a bit. And these games, of course, these were played in the terminal, and that's why this was possible. And this game, ADOM, it's since been made into a graphical version with music and everything, and that's great. And I really think this game is excellent. You should try it out if you haven't played before. There are many games like this. This is a roguelike game. It's a sort of procedurally generated for much of the content, procedurally generated game. But this game has an enormous amount of depth. It's really unforgiving, and it's really deceiving. You wouldn't think that the level of depth is there until you've really played for a while and you really get into it and you realize that everything that is there has a purpose, and everything actually connects together in a lot of different ways. Anyway, that's for a different time for you to explore. I want to just see if I can find some screenshots of ADOM. Of course, I don't have DuckDuckGo here, so let's see if we can find some of the ASCII screenshots. So it's something like this. I'll just accept that. So this is actually the ADOM wiki. And here you can see this is some part of the game where you're walking around, and there are a bunch of different things and apparently lots of different characters. Let's see. This is the overworld, and you move through this, and you can move into different parts. And for instance, these stars that are locations that you can enter into. So this is kind of how it is, and there are many games like that. And so for us, what I would actually like to do is to build something in the browser, something that can either be run in a web page or packaged into an Electron app to play, on the go as a regular app, but using this aesthetic. And sort of the end result will be something like this. So you can see here I've got a character here which is controllable with the keyboard, and you can see that the environment is sort of the character is in the middle, and there's some sort of kind of lighting effect that's happening with the character. So I actually want to make this a little bit more advanced than it would be in something like ADOM, where of course you're just rendering text into a terminal. I'd actually like to be able to make some interesting effects and to be able to have layers which layer over each other, and to really customize everything. And so I've actually been working on this already a little bit, but what I want to do is to recreate basically what I have so far, which is not a whole lot of code, and get it up and running, and then try and make a little game in it. Maybe an adventure kind of game, maybe not necessarily procedurally generated, but doing some interesting things with some pathfinding and some interactions and some sort of architecture of how you can put together a game. All right, so let's take a look at this. So let's clear this out, and this is the directory that I'm working in, but let's move into the LLJS directory, and we'll create, call it ASCII engine. Nice imaginative name, and we're going to npm init in here because we're going to create, we're going to use a bundler. We're going to use Parcel. Again, used Parcel recently. Parcel, and we're going to install version 2. No, okay. So if we install this version, then we'll get the Parcel 2, which has some improvements and fixes some bugs that I ran into in the previous version. And the other thing we're going to do in this project is to use TypeScript. Now, the engine itself can compile down to JavaScript, that's fine. But using TypeScript will have some really nice benefits, and will allow us to model the engine in a nice way. If you haven't used a lot of TypeScript, this could be a nice opportunity for learning. I'm not going to use super advanced features of TypeScript and crazy sort of type tricks or anything like that. It's going to be quite simple. I don't think we'll even have that many generics or anything like that. Quite straightforward. Just want to make something that's extendable and that's usable by the user or the game author in a nice way. Okay, so we're going to make a source directory. We're going to put an index file in the source directory. So let's touch source index.ts and index.html, and we'll need a ts config. So that's just, I'm actually just going to copy that from what I have in the previous directory. So ASCII engine ts config, copy that to here, and I'll show you what's inside. It's nothing too special. And that should get us going. So let's open this folder up in code. Alright, so in the ts config, what we've got is that we're telling the compiler that we're going to say that we're using elements from the DOM. So we're working with the browser. So we're going to have things like DOM elements, and those are typed. So we have those types available. And we're going to have the elements of ES 2017. Could actually bump this up, but I know at least I'd like to use some of the features of ES 2017. TypeScript makes us be explicit about that. We've got this down level iteration to true. I don't remember exactly why I had to add this, but it's something to do with destructuring and like multiple levels of destructuring in iterators. It might not actually be necessary. And we're targeting ES6, doesn't really matter, but we need to express that we have some kind of target which is greater than ES5 if we want to. I don't want to compile down to a bunch of code which will... We're just assuming we're working with modern browsers, and I think that makes for a nicer development experience. In the package JSON, let's add a script for start, which will simply run parcel on our source /index.html. And in the index.html, let's add a basis here. We'll call this LLJS ASCII engine. Need to include the script. The source of the script is just index.ts for now. And Parcel is smart enough to know just to work with TypeScript for us here. So it won't demand anything crazy from us here. We can just work with TypeScript and it will work as expected. Yeah, that's it. We probably will need to add some specific styles. Not styles, but style. For example, well, there's going to be, we're going to have a place that we're going to render into, but we'll get into that. So let's just check that this is running. So we can put that in here. Let's create a terminal. And we'll run npm start. So we're not running on port 123. Instead, we're running on this. Because port 1234 is actually being run for the other version of the ASCII engine. And we got our hello. Okay, so everything working so far. No styles yet. So we're going to have a bunch of elements, right? Basically, I want to do this with, we could do this with the canvas. So that's an option. So we could use the canvas to render text, which represents the different layers. And we could have different canvases, or we could draw into one canvas and sort of build up a rendering buffer. But what we're actually going to do is just render to HTML. And it's not that much, and there's not that many elements. And so for the most part, this should be an achievable thing for the browser. Yeah, this should work quite well. And it's quite flexible, and the text rendering's great, which is good for a text engine. And yeah, we should get really nice, crisp, clean output. So, right, let's start. We're going to have some different components. We're going to bring all of our components together in the index file, but we're going to have, for instance, a renderer, which is actually going to take care of taking our abstract drawing elements, and it's going to turn them into actually like drawing commands, so writing to HTML. And the renderer should be interchangeable. The renderer should be able to target different kinds of rendering, so we should be able to rip this out and put it somewhere else. For instance, we should be able to write a canvas renderer, we should be able to write a WebGL renderer, or we should be able to write a whatever renderer, whatever you want. Yeah, so for now we're going to work with the web. So we're going to have a renderer, which we're going to work with. We're going to have some sort of input controller or sort of input module that helps us out with input. We're going to have tiles. Tiles are going to be the base unit of all of this. And, well, those three things for now. I think we're mostly in this episode going to work with tiles and the renderer. So let's actually start out with tiles. So I'm going to add a tile.ts, and we're going to make a class. So we're going to export default class tile. Now, tiles are going to be made up of a bunch of things. One of the main things they're going to be made up is their character. So the text character that it represents. So let's make that. So normally in JavaScript in a class, you would express all your elements, all your members in the constructor. You can actually, in TypeScript, you can express this out of the constructor, and that allows you to know statically the types of these things. So we know that tile will have these members for sure. It's really handy. So one of the things we'll do is we'll say that we've got something called a char or a char. I like to say char. And that will be of type string. And that's it. So we'll load the value into it, but we'll always have a string, which is our character. We're going to have a color. And color, we could make that a string or something, but I'm actually going to make a type for color. We don't have it yet. I'm going to write a type for color. We're going to have a background, which is also going to be a color. And we're going to have a position. And that's going to be something called a vector. Oh, we don't have a vector yet, but that's something we're going to write. And a vector is just a position, basically, a coordinate. But a vector is a little bit more than that. It's a mathematical object that has operations that can be done on it. And we'll just write a small vector library for this engine, and we'll expand on it as the need is there. So we're going to have a character, a color, a background, a position. Perhaps we're going to have properties like is this visible, which would be a boolean, which would just tell the renderer that it doesn't have to draw this, or it can hide this or ignore this operation, which will be allow it to run a bit smoother. And I think for now that is all we need. So we can make a constructor for it, and we could just put these could just put these objects inside the constructor, but instead I'm going to take, I'm going to call it options, but it's probably a better word for it. And we're going to say that these are like the tile constructor options, which we also don't have right now, but we'll write that here, and we'll create an interface. And basically this interface is it just describes an object that could come in any form, and it must have a certain set of properties, or at least it has to meet these properties, and that's what we're going to make this for this object. This really helps people out that are using the library, because they can see exactly what they need to pass and exactly what the types are. So we're going to specify that they need to pass all of these things, but we can make some of them optional. For instance, we could make the character optional by adding this question mark, and then we would assign some default value. But it just means that they wouldn't have to provide this character to us. They might not also have to provide a color or a background. We're just going to make all of these options optional, as it were. And then what we can do is we can just set all of these. So I'll bring these in. And we'll just set all of these based on either what we get from the options, so either what we have here in the options, of a keyboard that doesn't actually have proper arrows, which means that it's always a nightmare to do these key movements. Watching someone type incorrectly is just nightmarish. Okay. Well, close enough. All right. So, for instance, if we didn't get a character, we'll just say that it's equal to space. If we didn't get a color, well, we don't have a color at the moment, but I'm going to set that to some kind of default. If we didn't have a position, we'll set that to some kind of default. And if we didn't have a visible value, we'll just say it's true by default. Okay, so let's get around to writing a color. Let's make a new class here, color, TS. It's kind of against my nature to write color in this way, but all of technology has it, so it would be a little bit selfish of me to insert a U in there. All right, export default class, color. This is really simple. Color is just going to be a container for RGB A values. So we're going to have a property, and that's going to be RGB and A. And I'm going to do that in a particular way. I'm going to create some private properties, which is something you can do in TypeScript, which is very nice. You can sort of hide the implementation details of your class without having to do something like using underscores as some sort of conventional thing. So we're going to have a private, I actually am going to use that underscore convention, but that's because I want to have something else called R. And that's going to be a number. So we're going to have G, we're going to have B, and we're going to have A. And we can actually assign default values to all of these things here, but we're still going to have a constructor. Here, we actually will just take RGBA values, we'll just make them all optional. It would be a bit crazy to provide some options thing here where you always need to provide these things. So we'll have R, which will be a number, and by default it will be equal to 0, and we'll just do that for all of those. So we've got G, we've got B, and we've got A. I'll make A actually equal to 1 by default, and let's make these 255. So the default color will be white, which is sort of, it's arbitrary, it's an arbitrary choice here. We could actually also make this just transparent by default, but I think that would be tricky if you're trying to just check if something is on screen. So I think having some value there is nice. And the reason I've chosen white versus any other color is that typically in these ASCII games, your background is black. So this will provide some contrast to see that something is actually on screen in that place. Okay, so this dot r equals r. Just do this like this. G, whoop, G, B. Wow. Saving time with key shortcuts. All right, so that's all we really need to do, and we'll need some thing like a toCSS string method on here, and we'll return a CSS string. What I'm actually going to do is create this CSS string up here. Also private, and we'll say this dot. Let's make a private method called make CSS string, and we'll say this dot CSS string equals RGBA, and then just our values here. So this dot R. A lot of repetitive. Okay. Okay, now the reason I've done this is because we're going to need to get this CSS string all the time. It's going to be like one of the most called functions in the entire engine, so we might as well make it sure that we don't have to build the string every time, and only change it when we actually write to these. So what we can actually do is we can create getters and setters for these. So let's have a get r, and with that we'll just return this dot underscore r. Again, we'll so G E A. All right, so now we can get those values, and then we'll create setters for them as well. And we'll take a value. Should be a number. It should actually be an integer, but we're just going to trust that the user has given us sensible, sensible values. It's their fault if they give something weird and it doesn't work. We're not going to do too much in the way of error checking. And whenever we do a set, we actually also want to call this make CSS string method. Could actually inline that code here and like make one less function call, but I don't. Yeah, well, if that becomes a problem, we'll tackle that. Okay, so far that is it. So yeah, now we've got a class that represents colors. Let's go back to tile. Let's bring it in. Import that in and say that if we didn't get a color, then we'll just make a new color, and it will be. We'll just make it white. So we can do it like that. And then for the background, if we didn't get one, then in this case, we'll make a black background. That's it. And the actually don't need to provide an A because it's 1, but I'll do it just for consistency. Now, next, vector. I'm not going to write the whole vector class here because there are quite a lot of operations that you would want to have. Before I do that, I'm just going to add one more thing to these classes, because this is clearly not immutable at the moment, and I typically like to write immutable classes. But immutability and writing games, they often don't go that hand in hand with each other. But let's make it really easy to work with copies of things. So I'm just going to add the clone method to everything. So anything that's not immutable, we'll write a clone method, and we will just return a new instance of it. So we'll return a new color, it just has this dot R. Let's do it like this so we don't go through this dot G and this dot underscore B. Okay, so to clone something, we just call clone and then we'll create a copy instance of it. Now for vectors, export default class vector. Vectors are quite straightforward. They have an X and a Y. We don't need to use getters and setters in this case because we don't need to recompute strings every time. So X is a number, Y is a number. Vectors are abstract objects that can have n dimensions. In this case, they're specialized in 2 dimensions, but you would in other game engines you also have like vector 3 and vector 4. If you've worked with graphics, you often work with 4-dimensional vectors, and if you're working with positions, you work with 3 dimensions. And we're working on something 2D, so we have 2-dimensional vectors. Create a constructor. We'll take in an X, which will be a number, and a Y, which will be a number, and we will just set those properties. This.x is X, and this.y is Y, and we have various methods here. Well, let's make a clone method right out the gate. Return a new vector with this.x and this.y. Less properties to type this time. So the base operations will be things like add, where we'll take another vector and we will return, well, in this case, this is going to be a mutable add. So we're going to take this.x plus equals v.x. And this.y is v.y. And then we'll return this. So we can chain these things together. But for every operation that we create here that will potentially return a new vector, I want to add a static method for the same thing. Because we will want to create immutable vectors often, or we won't want to modify the one just based on some calculation. So instead of cloning every time, what we can do is we can use a static method where we pass 2 vectors and perform the operation that way. So we'll have a v1, which will be a vector, and a v2, which will be a vector. And the simplest way of doing this would be to actually say v1.clone.add v2. So then we don't need to duplicate the method all over the place. Okay, we're going to need to add more operations than that, but that will do for now. So let's go back to our... Yeah, we'll bring in the vector. And so for position, just have a new vector which will start at 0, 0. So that's a decent default. Now we've got our tile, and yeah, that's it. So we've got our tiles can represent the objects in the game. Okay. So let's create. Well, before we go any deeper, we're going to have another concept here. So I want to have layers. So if I go back to the other open engine, what you'll see is that there are some layers here. There is the player, which is this red character here. You can see that actually below it is still what is drawn in the background. So there is a background layer and there is at least one foreground layer, and I would like to make it so that layers are arbitrary. And what layers really represent are they're really part of the renderer system, and they represent drawing buffers, essentially. The places where we want our operations to go, and then we can manipulate these buffers and eventually we commit them to the screen. So let's actually write a layer class. So again, we'll export a default class layer. And a layer is well, it's a relatively simple construction as well. It's going to have, for instance, an opacity value. So we can vary the entire layer's opacity. Also change its visibility. Make an entire layer invisible. A layer is going to have a size, so we're going to take up a particular amount of screen space. So, for example, here we see that this whole sort of game area, the background and the foreground, it has the size that goes from here to here, and that this below is actually a different layer, and it's offset from up here. So we actually move the entire layer down here, and it has a smaller size. It's not that this layer takes up the same amount of space. And so let's add a position and a size property to a layer as well. So we'll have a position. I'm just going to call it POS, just pause, because we'll type this a lot. And position is a vector. Size is also a vector because we have a size in the X direction and a size in the Y direction. Okay, and then after this, we're going to have an array of something called operations. So it's going to be an array, and it's going to be an array of something that I'm going to call a drawing operation. And we haven't written this yet, but a drawing operation will be an interface. We could make a drawing operation a class, but I think having it be a plain object for now will also work just as well. And a drawing object is not going to a drawing operation is not going to be that different from what a tile actually is. It's, you know, we've got a character, we've got a color, we've got a background, a position, and whether or not this thing is visible. We're actually going to have all of these operations, all of these things in here as well, but they won't be optional. They all have to have values. We need to bring in the color class. I also want to have a reference to the tile that this is sort of representing, this whole drawing operation. And I think for now that's enough, although I want to add a few more more elements to this later too. Okay, so we're going to have an array of drawing operations, and this is kind of this. I guess there's one more thing that the layer will have, which is a z index or a z index. Although this is less a property of the layer itself and more a property of how the renderer does its organizations. So we won't write that in directly. So we'll create a constructor for this. What we need to take in, let's make, do we have anything that could be a default? We've got position and size, but these will need to be provided. Or I guess position could by default be 0. So let's create layer constructor options. And again, we'll make an interface from this. So the whole thing with TypeScript, if you're using it in a certain kind of way, basically what you're doing is just trying to make it easily discoverable for your user to see, you know, what your interface that you expose to them. I mean, when I talk about interface, I mean like API here, like the library or the framework or the engine or whatever. It makes it easy for the user to see and discover what it is that we're exposing to them and how they can use it without having to read the documentation all the time. Because, for instance, they can just hover over vector here and they can see, oh, it's this class vector, and maybe they can click through to it and they can see what a vector has. And so, for instance, if I were to reference this size here, we could see we've got an add method, we've got an X and a Y, we've got clone. We would just know something about the API without having to do any reading of the documentation. It's right here in this place. And also, of course, there's a compiler which is going to check that the code you write conforms to these types and interfaces that you've defined. And that's also a helpful thing. yeah, okay, so the layer constructor options, we're going to need to take a position and a size and whether or not it's visible and the opacity. So let's just, I guess we can take all of those things and put them in, and we'll make everything but the position and the size. We'll make everything optional. And so what we're going to want to do is take these things out of the options, and if we don't have them, then we'll put something in there by default. So the opacity is a number, by default we'll say it's 1. Visibility will also set to true. Position by default is going to be vector, or rather new vector dot 0. Or no, I'm sort of giving away something here, but since we're going to use things like vector 0 a lot, what we can actually do is open up our vector class and add a static method called 0 and just return a new vector which is 0, 0. And the reason that we don't just create one instance of vector 0 and return it is because this is a mutable thing, and if we do that and someone adds something to it, then everything which referenced that 0 vector is going to be off. So if we can now do something like this, vector.0, and we'll get ourselves a 0 vector, which is unique. And size is not optional, so we can assume that they have given a size and it is a valid vector. And yet they could pass us negative numbers, they could pass us non-integer numbers. I'm not going to check for any of that now. I'm just going to say that if you provide a negative size, then I don't even know what that means. So what should I do with it? I could throw an error, but let's assume the user is responsible enough for themselves to not provide something like a negative size, and they can do the debugging for themselves and learn that lesson. Okay, so let's finally kind of write a little bit of code that puts this together. So let's create 2 layers. We'll have a background, or let's make an object called layers, and we don't need to do this, but let's do it anyway. Let's say that this is a record, and a record just allows you to say that every value in the object has the same type. So we're going to say it takes string keys and it maps into layer objects. And so we're going to make an object which has, let's say, a background layer. So it's a new layer. And we can provide some options here, and if I add IntelliSense, we'll see what we can and what we must supply. So all of these things, we don't need to provide them. We're going to start the layer at 0, 0. And the size, well, the size that this is going to be a new vector, Boolean vectors, and we're going to say that this is like old school terminal size for now. So 80 by 24. Now add another layer which is exactly the same, and it's going to be called the actor layer. That's where we're going to put like characters and NPCs and all of that kind of stuff. Okay, so now let's make, we need to add one more method, I think, to layer, which is going to be draw. And when we take a draw, we're going to take actually a tile, and that's going to push a drawing operation into the operations cube. So the way we do that is basically we're going to we could actually just push the whole tile, but for reasons that will become clear shortly, or relatively shortly, I'm going to have the drawing operation be a different thing from the tile itself. So how we can do this is, let's let's see, let's make a function here, just a plain function. It takes in a tile. And we want to just return an object from this. So yeah, we're just going to return these things. So the tile is just a tile. Let's take all of these, get rid of them. So the character is tile.character, char, tile.color. Background is just tile.background. That's the same for all of these. And okay, but actually I want to use the clone method on all of these things which are mutable. So we're going to copy the colors, we're going to copy the position, and all of that kind of stuff. And we'll see why. So we're decoupling the tile itself from the idea of drawing that tile somewhere. So we should label here that we're going to return a drawing operation. And that way, if we made a mistake, like we forgot to include tile, we'd actually get an error here because we didn't include tile and we needed it. Didn't actually forget anything, but it's a good idea if you're going to conform to an interface to say what the return type of your function is, so it's clear. Okay, when we draw, basically all we're going to do is we're going to say this dot operations dot push drawing operation based on this tile. That's it. Really straightforward. Okay, so now we can make let's make a player tile. And this should be much more advanced at some point, but one of the things which will become clear as we write this engine is the engine itself is going to be a relatively minimal set of files and a minimal set of functionality. And it will be up to a game developer to build more of a framework for how to make a game. So there are many different kinds of games you could make. One kind of game is like a roguelike game, but you could also use, this is essentially just a rendering target with some input and some helper functionality. So you could also build Pac-Man or Tetris or something in this kind of exact same kind of system. And you would want very different kinds of sort of game scaffolding in those situations. Like building Pac-Man is very different from building a DOM, which is essentially an RPG kind of game. Yeah, you need very different functionality. So it allows the programmer to build their own framework. So all of this would be abstracted in the sort of framework sense of the game developer. We're not there yet, so shouldn't go too deep into it. So we're going to bring in tile, and what do we need to supply? We need to supply a background for the player. I actually want this to be transparent. So say a new color, and it will be 0, 0, 0, 0. We could make a color.transparent static method. Actually, maybe I will, but we'll leave it for now. We also need to supply a char. Well, in a DOM fashion, I'm going to have that be the @ symbol. We need to supply a color. I'm going to make that red. So new color, and we'll just have that be 255. We don't need to pass more of those because by default the rest will be zeros and a 1 for the alpha, which will be red. And we need to supply is visible, will be visible, and we need to supply a position. We'll start at 0, so vector.0. Okay, so that's our character. We can render that onto the actor layer. We're also going to have some kind of background. So I'm going to create an array of background tiles here. And we've made our game 80 by 24. So we need 80 times 24 tiles. So we can make an array of 80 times 24. And for every one of those, So we can turn those into X and Y's, and we talked about this actually in the Fantasy Game Console series, if you haven't seen that. But in the Fantasy Game Console, we talk about how we can get X and Y from a one-dimensional array. And the way you do that is you take your index and you use the modulo operator on the width. So the width is 80. And to get the Y position, you take the floor, the mathematical floor, so division rounded down, of I divided by 80, so by the width. And you should really put these things into constants, which I will do actually. Const width 80 and heights 24. In these places where we've mentioned 80, we'll instead mention the width. Somewhere I misselected. Width, and anywhere we've mentioned 24. Turn it into heights. Good. Okay, so we've got an X and Y position, and just to make the background a little bit different, although I guess it doesn't really matter. Let's leave those calculated, and let's say that we're always going to have a tile where the character is, I don't know, let's make it a dot, and let's say that the only other thing we really need to provide is the position. We don't need to provide it, but that will be a new vector at xy. And that's it. And we'll just make every pixel a dot for now, but we can change that in a minute. Okay, so now height equals height equals 24. What we could do is we could take our layers, so like layers dot background, and we could draw something into that, and we could draw background tiles. To do that, we'd actually need to loop over them. So background tiles dot for each tile, and we want to draw that tile. Okay, and then layers dot actor. I found something wrong here. Why don't I have this? Not quite sure. I feel like I've made a mistake somewhere here. This is all closed properly. Okay, that will be the player. Okay. Of course, that doesn't do anything at the moment because we don't actually have a renderer. We've got nothing to draw those things, but we do know that we have can console log the layers out at this point, and we can just view those. Can't read property push. Oh, okay, we didn't initialize the operations array. That is true. So in layer, we've got operations, and we could initialize it in the constructor. We can also just initialize it here. Should take care of that. Okay, so if we check here in the actor layer, we have operations, and we've got this thing which describes all of the different operations. We have reference to the tile, and in the background layer we should have a ton of operations. We have 19, 20 of them. Yeah, and we need to translate these operations into screen elements, essentially. So let's begin writing the renderer. Again, it'll be a class. And we're going to have a few different things here. We're going to have some layers, and the layers are going to be named, and they're going to have Z indexes and all of that kind of thing. So let's just start out with what we know. We're going to have a stack of layers. Let's call this named layers, which is a record of string names to layer objects. That's one of the things we'll have, and I'm going to initialize that to an empty object. What we're also going to have, make all of these things private, because the user shouldn't interact with any of this stuff. What we're also going to have is an array of these, which is going to represent the order of the Z indexes. And we'll just have, in this case, an array of layer, which we can set to empty array. And let's start this out with like an add layer method. What we're going to need in that is a name. Names are strings. We're going to need a layer object itself. Now let's first take a Z index. So the Z index is going to be a number, and then we'll take the layer. So, and then at the end we don't really need to do this, but make a fluent interface so we can chain together these add methods. Okay, so it will be worth checking that we don't add the same layer more than once, even though the player can make sure, the programmer can make sure of that. If maybe it's worth doing that as part of the engine. So what we want to do is we want to check that this name is, if this name is in the named layers, that should be an error. So return a new error. We can make specialized error types. Won't do that for now. And it's just going to be name layer already registered, already attached to renderer. So that will be the user's responsibility to fix. And what we're going to do is we're just going to simply add that, this dot named layers, the name, it's going to be this layer, and to put it into the array, it's not the smartest way of doing this, but all I'm going to do is I'm going to just push it into the array at whatever position. I'm not going to try and insert it, and I'm just going to have a private method called compute, well, order layers. And all this is going to do is going to take our layers array and this.layers.sort, and we'll take in a layer A and a layer B, and we'll just say if we should make the Z index part of the layer itself. Although then if we change, the difficulty here is that we need to keep these Z indexes around. But the thing is, if it's part of the layer itself and the user alters the layer or tries to write over the Z property, I guess we could make it only a getter. Okay, so let's say we need a Z property as well. Make it optional. I'm going to put that as a private variable underscore Z number, and this dot underscore Z will be equal to options.z or 0. And we'll have a getter for Z, which will just return this dot underscore Z, but you can't overwrite it. And we'll have, I'm not sure about this mechanism at the moment. I don't like the way I'm setting this up right now. I'm going to revisit it, but just to keep going for now, we'll assume that layers now have a Z property, so we don't need to pass it as an argument. And when we order them, we'll just say that layer Z, layer A.Z, take away layer B.Z is the way that we sort them to arrange the different parts. And that should make it so that lower Z indexes are drawn before higher Z indexes, and therefore we stack them correctly. Yeah, it's not the best mechanism. I'm not completely thrilled with this because it doesn't allow the user to easily reorder them, and they specify the layer order in the layer itself. But then to change it, you'd have to go through the renderer, unless the layer itself has a reference to the renderer, which is kind of a difficult ownership sort of model. So I'll think about how to change this later. All right, so now we can add layers, and they order themselves correctly. We're going to need two things here. Well, we're going to have a commit method. And when we do commit, that's going to take all the drawing operations which have been specified in the layers and actually draw them. And then at the end, we're going to clear the operations out of the layers, and we'll be ready to draw new things again. I'm actually going to add one more method then in here, which will just be clear. We'll just set this.operations to back to empty array. Okay, so what do we want to do here? We want to iterate through the layers and start making HTML elements. So in the index.html, let's say we need to provide some sort of, we could have the game generate these things automatically, but let's say the user has to provide a little bit of structure. So just at least a container for the layers. I'm going to say that we have a div that has an ID of ASCII engine layer container. So the user is obligated to provide us with this layer. I guess here in the style, one of the things I want to do is to say that anything is going to have a font family, and I actually want to use Inconsolata. So we want to use Inconsolata. This actually is not a font that everyone's going to have installed on their computer. I do have it installed on my computer, but you need to use a Google font. I don't want to actually go to the trouble of adding this whole Google font at the moment. This will work, and it will fall back to a monospace font like Courier otherwise, which will work equally well. And what do we need? Nothing else here. Do you want to make the body take up 100% height and width? Width 100% and height 100%. And I'm going to add just a little bit of CSS for the layers themselves. So we're going to have a class called ASCII engine layer. And we'll say that this is going to be position absolute, because we want to move these things around within the relative space of the ASCII container. So I'm also going to set that up quickly, that this is position relative. So all layers are going to be absolutely positioned. We'll compute the actual positions in the engine, and we want to make the overflow hidden, so that if something draws outside of the size, we don't actually see it on screen, like just wandering off the screen. We might need to write some more CSS, but I'll leave that for now. Okay, so what we want to do is we need to find like layers that correspond. And if we don't have those layers, then we're going to need to make them at least the first time in the engine. So let's iterate through every layer that we have. So let's say we get name and layer by iterating through this.named layers. And we can't do it like that. Of course, we need to use objects.entries. So now we get the name and the layer, and we can check if we've created one of these things before. So to get the element itself, well, let's keep a private cache of that as well. So let's say private layer elements, and you could see that we could store some of this stuff together. For now, I'm making it kind of as I go along, and we'll optimize the layout later. So layer elements is also going to be like taking the name and associating it with something else. So we're also going to be a record, but it's going to be a record that maps to an HTML element instead. So what we can do is we can say that the element we're dealing with, let's call it the layer element. The layer element we're dealing with is this dot layer elements name. Now we may or may not have one of these, so if we don't have it, if we don't have a layer element, then we're going to create it right now. So we'll say layer element equals, and we can't have constant, layer element equals document.create element. We'll just make it a div. There's no reason to go anything fancier than that. And we're going to need to set up the properties of this thing now. So like we know the size, and we know the size, and we know the position and the offset and all of that kind of thing. So we can say that layer L dot add class. It's going to be an ASCII engine layer, just like we set up. So it's going to get that position. No, it's class list dot add, and so this is going to inherit the position absolute stuff. So it's already correctly set up. We need to position it. So layer L dot style dot so the top is going to be, so the layer dot position dot y. And now this only talks about tiles. We haven't like spoken about the size of the tile, and the size of the tile is going to be the font size. Like we're going to discuss this in terms of the font size itself. So we're going to keep also a record of like what the font size of the renderer is. So I'm just going to call that size, just a number, and we'll start at something like 20. Let's start at 30. I think that will work better with the for the video. So we'll take layer position y, and we'll multiply it by this dot size, and we'll just apply that as a pixel value. And then the left, well, the way that this font is set up is that this is actually going to be like half the size. So it takes up half the size of the, so we're actually offsetting only by half. Could offset by the whole amount, but then we'd end up with these weird holes everywhere. So we've set that up. We need to set the size. So the layer element dot width is, or style dot width is also going to be computed in a similar kind of way. So instead of doing the position stuff, it's only related to the size. And the height, oh, that's not true. It's layer.size.x in this case, multiplied by size over 2 for the same reason. And the height layer.size.y multiplied by the size without dividing it by 2. Let's put that above. So we've got top left and then height width. Okay, then we need to add this to the container in the right order. And the way that we can impose the ordering, of course, is to use Z indexing. We don't need to do anything fancy here. The Z index is just on the layer itself. So layer.z, don't need to do anything too crazy here. Not assignable to string. Oh, this is a string because it's a CSS property, so it's easily solvable. Not something that JavaScript would ever worry about. It would just implicitly convert that. Okay, so I think that's most of what we need to do. We need to add this to the container, the layer container. So document.getElement by ID. We don't need to do that. That's going to be ASCII engine layer container, I believe. That's what we called it. ASCII engine layer container. And then we're just going to append child layer element. And then we need to add it to our cache. So this.layer elements name becomes layer L. Okay, so now we have a layer element. We don't need to worry about that. That's definitely been created. And we now need to more worry about the things inside. So for this layer, we need to render out all of the things we have in the operations. So let's make another loop where we're going to iterate through operations, and it's going to be of layer.operations. So we're just looping through the array now, and operation is a specific type, so we know all the operation things we have here. Background, char, color is visible. And these are also going to be HTML elements, and it's not that we're going to render out line by line or anything. We're going to make a bunch of individual HTML elements. And it might seem a bit crazy, but it should work. It should be fine. The browser is already a very optimized renderer. So this is probably going to work better than anything we would try to do anyway, and we can fall back on all of the CSS properties that work really well as well. Things like display to turn on displaying or not. Now the only thing is that these operations are going to be related to tiles, and we probably don't want to like clear out the entire DOM every time and write it back in if we don't need to. That is maybe a little bit on the edge of what might not work in terms of performance. So one of the things I'm going to do is I'm going to go to the tile class. Should have named this with capital T. Can do that. I'm going to go to the tile class and I'm going to add a property to it. I'm going to make it a read-only property, which is another nice thing you can do in TypeScript. True constant. I'm just going to call this ID. It's going to be a string, and a nice simple way of making unique IDs, although it's a little bit hacky. It's just to use math random and then turn that into a string of, it doesn't really matter, you can, the maximum sort of base you can turn that into is 36, and then slice off the fractional, the integer part, the 0 point, slice that off, and then that should give you an ID which is quite, long enough and likely to be unique enough that we won't get collisions from what we're doing. Pretty unlikely. So we can use this to check if we have any given element. If we have an element that corresponds to a tile. So the tile that this corresponds to is op.tile, right? And now we have access to this ID. So we can see if we have an element. So let's call it op.l, will be something like document dot get element by ID, and the ID will be ASCII ASCII engine. I'm just going to prefix all of these things with ASCII engine just to assume that we don't mess up namespacing. ASCII engine tile, and then we'll reference our tile ID in here. Need to make this a template string. Actually, I have an extension that should, if I do this, turn it into a template string. And then, of course, if we don't have this op element, then we can just create it. And that's super simple. We're going to do it in a very similar way, so I'm just going to copy this. So if we don't have an op el, and we won't do too much, we won't set too many properties in here. Let's also make sure that we have a class. That's another one of the things we need to have. So if we have a class for an ASCII engine tile, it also needs to be position absolute, because we need to position it absolutely. What we're going to do is we're going to say that we're going to create an element that will be a div, because again, why not? And op-el should not be const. We create this element, we're going to add ASCII engine tile, and we're also going to give it an ID. So this should be, let's make sure we don't make this mistake. We're going to give it an ID, so op-el.id equals, and then it will just be ASCII engine tile excellent. And I actually won't set any of these properties here because we're going to need to set them every time we do the drawing operation anyway, so we'll just do it outside of here. So we create the element, and then we want to add this to the layer because it doesn't exist. So we already have the layer element. We can append the child operation element, and we're not going to cache it anyway. We don't need to keep track of these individual tiles just to make sure that they are there. Although we could keep track of cache, but maybe we don't need to. If this operation seems to be expensive, then we'll do it, but otherwise not. Okay, so now we have an element. Basically, we need to address these parts. It should also be. We should also set the font size of the layer so that every element inside doesn't need to set its own font size. So layer l dot style dot font size, and that's going to equal this dot size. Pixels. Yes. So call it the inner HTML. Could be text content, but it's this. There's a reason that I'm doing it in this way. The inner HTML of this operation element is going to be the operation character, and we're going to replace any instances of spaces, all instances of spaces, with the HTML non-breaking space character. Because HTML, if you have more than one space, or if you use a space, then it's going to actually do weird things with it. So this will help us out with that. So we are overwriting the space. We're setting actually the character already, but we need to set up a bunch of stuff in the style, like the color, and that's just going to be op.el.color. Sorry, op.color.toCSS string. Then the background color, that's going to be background.toCSS string. What else do we have? We've got the position, of course. So we know how to do that already. op.el.style.top is going to be op.position y multiply by this dot size pixels. The left part is the x, and we divide that by 2. And what else do we have? We've got the whether or not it's visible, and that's it. So what we can do is we can actually see here, if op.is visible, then we're going to do these things. And at the end, just to make sure we do cover it, we're going to say style.display equals block. We're going to use the display property to control its visibility, and otherwise we'll just set its display property to be none, and that will be very fast for turning visibility on and off for sprites, tiles rather. Okay, we've found the element, we've made sure it exists and is on the DOM, and we've set up its properties. It should be, I believe that should actually work. And at the end of the commit, we need to clear all the layers. So when we've done all of these things, we need to ask our layer to clear itself. Otherwise we'll be drawing the same things again and again. Okay, so here we've made our layers, we've drawn things to it. Let's make a renderer. We need to add these layers, so the renderer.add layer, we're going to add a background layer. Could actually loop through the object and do this. Layers of background. This is just a test, so we're not trying to write all the abstractions for frameworks now. So we've added these layers. Here we've already done some drawing operations. So if we were to call renderer.commit now, could expect, if I can spell, we can expect that I made an error for sure. But when we find out that it works, well, that actually is almost right. So we've got our character here, and we can like highlight all this text, which is probably not very useful. That's quite interesting. The background part is not highlightable. Let's take a look in the DOM here, how this looks. So here we've got this layer and this layer. So this will be the background layer. So this has all of our background elements with all of our IDs that have been generated. And this part has just the player. Its background color is transparent. Oh, okay, so I actually did set the default color as white. So that makes sense as to why it's not red as I expected it to be. But that's easily solved. Excellent. So now we have a background. We've got a player. Let's just spend a couple of minutes moving the player around just to see the rate of which we can render. Okay, so we won't write the input class now because there's quite a bit that goes into it. But let's just take the document and add an event listener to it. And it will be the key down. And we'll want to take the event object itself. And we're going to switch on the key that was pressed, so e.key. And in the case that it was arrow up, we're going to take our player, we're going to take his position, and we're going to add new vector, which will be 0, and to move up we need to go -1, and then we'll break, and we can add these things for the 4 directions. So for down, for left, and for right. And what we could do is we could, yeah, at the moment, since we don't have any like ability to hold down keys or anything like that, we will simply run all of these drawing operations again. So we'll take these, yeah, we should establish this before this. We'll run that one time. Let's put this into a function called draw. And we'll call draw once, so we get the first state of the screen. And we'll call it again every time we press a key, whether we press the direction key or not. Excellent. And that scrolling that's happening is because of HTML, so let's go in and get rid of that. So the body will get overflow hidden to prevent scrolling. Maybe it's actually, maybe let's put that on everything. It's sort of not very fair to the programmer to do that, but it will solve this for now. Actually, it doesn't solve this for now. So what has a scroll bar right now? Unexpected token. Is that correct? I'll check out how to fix that. But here we have the screen updating quite nicely. That's a decent speed. Now, just for the last couple of minutes, I want to show one cool thing that we can do, and the reason that we abstracted away the drawing operations from the tiles themselves, because we could just take a tile and draw it, right, with a position. But the reason that we don't do that is so that the renderer gives us a moment where we can actually get in there and change the buffers. So we're going to keep track of a private on before draw, which is a function that goes from void to draw, from no arguments to void. We'll expect the player to have access to this kind of stuff, and we'll set that initially to just a function that does nothing. So this is actually really a default. I guess we don't need to do that this way, but what we'll do is when we go to commit, before we actually draw anything, we'll call this.onBeforeDraw. So, and let's add, we need a way to give ourselves an on before draw. So let's say on before draw. Let's actually not call that on before draw. Let's just call that before draw. And on before draw is where the user will register their function. So they're going to take, they're going to pass, let's call it a callback, and that we know already is just a function from nothing to void, and we'll just set this dot for draw equals CB. And now, okay, so before we draw, what we'll do is we'll go into the, let's say, renderer, the on before draw, pass in our callback, and we'll actually here in this moment modify the buffer somehow. So what we can do is we can say, for example, that we want to make an effect on the background. So we'll take the background layer, layers.background, and all the operations that we have. For each one, we'll sort of let's modify the alpha value of the color according to something. So let's take the position of, so we say new alpha. So the new alpha value is going to be like math.sine. So we'll use the sine functions to create some interesting part here, and we'll take the position x and we'll add it to the op.position.y, and we will take that, and this gives us a value between -1 and 1. So if we add 1 to it, we get a value between 0 and 2, which is still a little bit too high. So if we now divide that by 2, that gives us a value between 0 and 1. So we can use that as an alpha value. So we just say op dot the color of the actual tile itself, set the alpha property to be new alpha. And so if we go back to our window here, now we get some interesting effect on the background. We didn't have to do anything with the tiles, we didn't have to set up some special handler on the tiles, but now we've got a cool effect. And if we were to do something like track the number of frames, we'll actually do this in the renderer, but let's actually do it in the renderer. So we'll create a frames, which is a number starting at 0, and on commit, or at the end of commit, we'll just increase the frames. So this dot frames plus. And so what we could do is we could like add renderer.frames in here, divide that by a number so it's not too high, and then maybe we need to the problem here is that we're not rendering continuously, of course, which is fine. Let's actually make it so we render continuously. Let's do request animation frame draw as the callback, and now our input should still modify the position, and we shouldn't call draw, just pass draw. And I had expected that that would have worked without. That's interesting. What's going on now? So we're doing commits here, modifying positions. So before I did that, does that work? Perhaps this tab has just crashed. Alright, so that seems to work. Let's add this back in. So here we go. Now we've got like a nice rendering effect. We're quite slow. We could increase the speed of this by actually making it on frames 10 times faster. And this ability to get in there and modify the buffers of the different layers really affords for turning this like what is quite a limited drawing medium into something that's much more interesting and can really tell a story in a game, I think. So yeah, I think this is a good place to leave it. We'll continue work on this in another video and eventually start working on a game. Well, thanks for watching, and I'll see you next time.